Welcome to this video which covers the full solution to the practice questions from lesson 22 using augmented matrix for basic vector applications. For the practice questions, you were asked to solve the following system of equations using row reduction. First one is a 2 by 2 system, so we get two equations and two unknowns. So let's try that one out. We're going to put our coefficients. So coefficient of x is 3, coefficient of y is -4, and that equals to 2 on the first row. And for the second one, we have coefficient of x as 1, coefficient of y as 2, and coefficient, or the constant, as 4. The goal here is to reduce the bottom left-hand corner to 0, so we want to get this to 0. And we achieve this by finding the lowest common multiple between these two, that's 3, and figure out what we need to multiply this to get 3, that's 1, and this by 3, and that's 3. So we will write our augmented matrix again. We're going to keep the first row as is, and for the second row, we are going to say that our new row is going to equal 2. We need to multiply this by 1, so that's just R1. And to get 0 here, we need to multiply this by 3 and subtract them. If we subtract them, we get 0. If we add them, we will get 6. And obviously, we don't want 6 at the moment. So that's 3 times R2. And when we do this, we will get, for the first column, we're going to get 3 minus 3, which is equal to 0. For the second column, we are going to get -4 minus 3 times R2, that's 6. So that's going to be -10. And for the last row, we are going to get 2 minus 3 times 4, which is 12, and that's also -10. Once we are at this stage, we can start solving for everything. So since we got a 0 here, we can go ahead and solve it. Or we can do another one as well, just for the sake of this video, I will show you that we can just go a little bit further here. I'm going to keep this as 3, -4, and 2. And this is just using solving, we'll do the exact same thing. The 0 is going to stay there. Our new row 2 is going to be the one from previous one divided by 10, or -10 in this case. And this will make this one and this one as well. Now there is another method of solving this. So once we have it here, actually let me solve this so you can see it. We're going to use the last row. We will use this one, and this one says that coefficient of y, which is 1 times y, which is just y, is equal to the constant value there, 1. And then we are going to use the first row here, and that says that 3 times x minus 4 times y, in this case our y, actually I'll write it out, 3x minus 4, our y value is 1, and that's equal to 2. So that's 3x minus 4 is equal to 2. 3x is equal to, I'm going to add 4 to both sides, and I will get 6. And then I'm going to divide both sides by 3 to get x value of 2 as my final answer. You can always go back and plug in everything back into the original equation just to check your answers. So in the first one, 3 times 2 is 6, minus 4 times 1 is 4, 6 minus 4 is 2, that's correct. And on this line, we have to check both, or if it's 3 systems, you have to check all 3. X is 2, plus 2 times 1, it's 2, so 2 plus 2 is 4, so that's correct. Left-hand side does equal to the right-hand side. I'm going to show you, this is a little bit outside of what I have taught in the lesson, but I'm going to show you one extra step that you can use to really reduce this so you can get all the answers right away. I'm going to leave my final column as is right now because I have one here, and it's really nice to have 0, 1, 1 or 0, 1 something because you can solve for it. It's z right away. But when you have the 1 here, you can also reduce this value. All you have to do is multiply this by 4 in this case and add it to this row. So actually, I'm going to erase my first one. And my new row 1, this is, right now we're dealing with 1, 2, 3, okay, so this is our third, is going to equal to the least common multiple of these two is 4. So I have to multiply this one by just 1. So this is going to be R1 from last set. And I need to add it to 4 times the last row 2. And what will end up happening if I do this? I'm going to write my values in purple. So row 1 is going to equal to the previous one, which is 3 plus 4 times R2. In this case, we'll end up just getting 3. So I'll write it out actually. So it's 3 plus 4 times 0. That makes it just 3 here. And then for the next one, we have negative 4 plus 4 times 1, and that makes it 0 here, so I'm going to put 0 here. And for the constant, it's going to be 2 plus 4 times this value over here, which is 4, which is 1, sorry, so that's going to be, yeah, it's going to give us a 4 as a final answer. So this ends up being 6. And once we have this, we can actually reduce it one further, and I'm going to do that here. And I'm going to say that row 1 is equal to the last row 1 divided by 3. And I'm going to get 1, 0, and 2. So 3 divided by 3 is 1, 0 divided by 3 is 0, and 6 divided by 3 is 2. And here I will leave it as is. And you can see that by doing this method, this is another method that we often use to reduce our matrices, and especially when we're programming things, this is a very good method, and it's much it's pretty easy to do when you're programming. So you can actually get these two to be 0. So you want the bottom left corner and the top right corners to be 0. And then your x value will be 2 and your y value will be 1. And this is another method. Again, you don't have to use this, and sometimes it requires a lot more work to get to here. And once you have it in the echelon form, you can right away go and do this. And sometimes it's just faster to do this compared to this method. So both methods are valid, but I just wanted to show you that both methods are available. Okay, let's do part B now. Part B has 3 equations and 3 unknowns. So I will make a matrix, and my coefficient of x for the 3 are 5, 2, and 3. And the next ones are negative 3, negative 2, negative 4 for y, and for z there are 2, 5, and 2. And my constants are 3, negative 8, and negative 2. My goal here would be to reduce the left bottom corner to 0, so this, and this, and then I can start solving. So first of all, let's write the first row. I'm going to keep the first row as the same. You can always interchange the rows as well, but in this case, I'm going to keep it the same. 5, negative 3, and 2, and 3. Row 2 is going to change because I want to make that first value to 0, and row 3 is also going to change. For row 2, when I look at the coefficient of these two, the lowest common multiple is 10. So I have to multiply row 1 by 2 and row 2 by 5. So we got row 1 being multiplied by 2, and row 2 is being multiplied by 5. And to I get a 0 there, I need to subtract the 2. So always look at the signs after. If they're both positive, then you have to subtract them. If one is negative, then you have to add them. And if they're both negative, you also have to subtract them. So once we have this, we can start calculating the values. So for the first column, 2 times R1 is 10, minus 5 times R2, that's minus 10 as well. So that gives me a 0, which is exactly what I want. For the next column, I will have 2 times negative 3, that's negative 6, minus 5 times R2, that's negative and negative make it positive, that's plus 10, which will give me negative 6 plus 10 is positive 4. And for the next column, I will have 2 times 2, which is 4. I will have 5 times 5, which is 25. And that will give me negative 21. And then I will have 2 times 3, which is 6 for my constants, minus 5 times negative 8, that is positive 40, and that gives me 46. Now for our next row, we need to get this 3 to 0, and we can use either this row or this row. It doesn't really make a difference. I will use maybe this row over here because the numbers are a little bit nicer. We don't have the 5. And between these two, the lowest common multiple is 6. And that means we got to multiply the second row by 3 and the third row by 2. So I will do that. And to get 0 here, I will need to subtract the 2. So doing the calculations here in purple, 3 times row 2 is 6, minus 2 times row 3 is 6. That will give me a 0 here. So let's put that down. And then 3 times negative 2 is negative 6, minus 2 times R3, which is negative 8. And that will give me positive 2. Then 3 times 5 is 15, minus 2 times 2 is 4, and that will give me 11. And lastly, I will have 3 times negative 8 minus 2 times negative 2. And negative 24 plus 4 is negative 20. At this stage, I have these two as 0. The only thing that I need to change to 0 is this one over here. So let's write our matrix, and I'm going to keep the first row because in the first row I don't have to change anything. I can just keep it as is. So 5, negative 3, and 2. And I will have my first value here as 3. I'm not changing anything about the second row. I'm really happy with it. So I'm going to keep it 0, 4, negative 21, and 46. Note that if there was a situation where I could simplify these or divide them by the same value, I would. So in this case, I have 4, negative 21. So we know that negative 21 can't be divided by 4 or any of the divisors of 4. So therefore, we're not going to change anything about this row. Now, since our goal here is to change this 2 to a 0, we need to use this row. And we will use this row because we got the 0 and the 0. And if we multiply both of these rows by any value, and if we were to add them, we will always get 0 plus 0 is equal to 0. So that would make it very easy to have the first value as 0. If we were to multiply this by something and add it to this, we will never get 0 here unless we had a 0 there as well. So let's do this. We got our third, and this is the second time we're doing this, is going to equal to the lowest common multiple between these two is 4, so I have to multiply the first, the row 2 by 1, so it's just going to stay as row 2 from previous augmented matrix, minus 2 multiplied by row 3. And this is going to be the last one as well, so I gotta show that using the prime here. Okay, once I have this, let's do this calculations here. For the first one, we get 0 minus 0, which is equal to 0. I'm just going to write that one down. After that, we are going to have, this one doesn't change, so we're going to have 4 minus, we're going to have negative 21 minus, and we're going to have 46 minus. And for the row 3, we're going to have 2 times row 3, so we are going to have 4 for the first one. We are going to have 22 for the next one, and we are going to have negative 40 for the next one. Okay, so 4 minus 4 is 0. Negative 21 minus 22 is going to be negative 43. And 46 minus negative 40 is same as 46 plus 40, which is 86. Now at this stage, we can go ahead and solve every single row. So we are going to do the bottom row first here. We are going to have negative 43 multiplied by z is equal to 86. We're going to divide both sides by negative 43 to get z value of negative 2. Once we have that, we can go to the second row and solve this. So here we will have 4 multiplied by y minus 21 multiplied by negative 2 with the z value coming from the last answer, and that's going to equal to 46. So 40y plus 42 is equal to 46. I'm going to subtract 42 by both sides, and I will get 46 minus 42, which is 4. And divide both sides by 4 to get y is equal to 1. Nice round numbers, this is beautiful. You may have situations where you don't have these nice round numbers, but in this case we do, so we'll take it. And we are going to use the first row now, and we are going to have 5 multiplied by x minus 3 times y. My y value was 1 from the previous step, and plus 2 times z, which is negative 2. That's going to equal to 3. We got 5x minus 3 minus 4 is equal to 3. I'm going to add 3 and 4 to both sides. I'm going to get 5x is equal to 3 plus 4 plus 3, which is 10. Divide both sides by 5 to get x value is equal to 2, and I get another very nice round number, and this will be my solution for the x, y, z. And that would mean that if I were to plug in x, y, z values that I found here, left-hand side will equal to the right-hand side for all of these 3 equations. And you can also check that if you want. Let's do one other example here. I'm going to draw my matrix here. And I'm going to try to solve this in 3 sets of matrix. Usually 3 is enough to get it to echelon form. So I'm going to start with the first one. My coefficients of, actually I'm going to start with the columns. My coefficients of x are 3, 2, 1. My y are negative 1, 1, and negative 3. And my z are all 1. And my constants are 8, 3, and 4. Note that in this question, because the coefficient of x here is 1, it would have been nice to move the 1 all the way up and use this as our first row, but and again, that's a more efficient way of doing this. But in this question, we'll leave it as this. It shouldn't make a difference, and we should get the same answer either way. So we're going to keep our first row to be the same because in echelon form, we don't really care about that. And for our second row, we are going to look at these two coefficients, and we got 3 and 2. The lowest common multiple between them is 6, so I would have to multiply the first row by 2 and the second row by 3, and to get a 0 I need to subtract them. Let's do that here. I'll do it on top here so you can see. 2 times R1 is 6 minus 3 times R2 is 6, so our first value is going to be 0. And I'll do all the 2 times first. So 2 times R1 is going to be negative 2, 2, and 16 for the coefficients of y and z, and then the constant. And we're going to subtract that by 3 times r2. So 3 times r2. For x, it would be 6. For y, it would be 3. For z, it's going to be 3. And for the constant, 3 times 3 is going to be 9. So now I can put the values in. 6 minus 6 is 0. Negative 2 minus 3 is negative 5. 2 minus 3 is negative 1. And 16 minus 9 is 7. For the next row, we want to change this to 0. So we can either use this or this. It doesn't really matter. Let's use the second row. It's got a little bit easier numbers. So R3 here is going to equal to, the lowest common multiple between these two are 2, so I would have to not change the first one, which is very nice. So row 2. And for row 3, I have to multiply it by 2. And in order to get a 0 right here, I need to subtract these two. So I will do my subtract sign in here. And now we are going to find the values here, we're going to keep row 2 as is. So it's going to be, do it in purple, it's going to be 2, 1, 1, and 3. And I'm subtracting that by 2 times R3. So 2 times R3 for the first one is going to be 2. For the next one, 2 times negative 3 is negative 6, 2 times 1 is 2, and 2 times 4 is 8. Once I have these, I get 2 minus 2 is 0, 1 minus negative 6 is 7, 1 minus 2 is negative 1, and 3 minus 8 is negative 5. Okay, now I have zeros here. I need to change this to a 0, and I need to use this row. And I can't reduce this row to anything else because I have negative 5, negative 1, and 7, and they can't all be divided by the same integer. So let's write the first row as is. So that's going to be 3, negative 1, 1, and 8. The second row is not going to change anymore, so that's 0, negative 5, negative 1, and 7. And for our last operation here, row 3 is going to equal to, we are going to use the lowest common multiple between these two, which is 35 in this case. So the negative 5 needs to be multiplied by 7. So 7 times R2. And the row 3 needs to be multiplied by 5 here. So that's 5R3. And in order to get 0, I have to add them. So that would mean 7 times negative 5 plus 5 times 7. So I will put an addition mark here. Now for our operations, we are going to have, for the different columns, 7 times R2, we're going to get 0. We are going to get negative 35. We are going to get a negative 7, and we are going to get 49. And we are adding 5 times row 3 from the previous step. So 5 times 0, we get 0. 5 times 7, 35. 5 times negative 1, negative 5. 5 times negative 5, negative 25. Let's add them all up. 0 plus 0, negative 35 plus 35, negative 7 plus negative 5, and 49 plus negative 25, it should be 24. Now that we have reduced it to echelon form, meaning that we have the zeros in the left bottom corner, we are going to start with the last row. And our equation here is negative 12 times z is equal to 24. This, if we divide both sides by negative 12, we will get z is equal to negative 2. And then we are going to use our next row. Let's use this one, or second row. And we will get negative 5 times y minus 1 times z, which is negative 2, is equal to 7. That's negative 5y. Negative 1 times negative 2 is plus 2 is equal to 7. Negative 5y. Subtract 2 by both sides to get 5, and divide both sides by negative 5 to get negative 1 for our y value. Finally, we are going to use the first row to finish answering the question. We will have 3 times x minus 1 times y, which is negative 1, plus 1 times z, which is negative 2, and that's going to equal to 8. We have 3x plus 1 minus 2 is equal to 8. Let's use one more step here. Minus 1 is equal to 8. I'm going to add 1 to both sides to get 3x is equal to 9, and I'm going to divide both sides by 3 to get my x value as 3. And I'm going to highlight all my answers, and this would mean that if I were to plug in x value of 3, y value of negative 1, and z value of negative 2, in these set of equations, they would all, left-hand side of them will satisfy the right-hand side. I hope that this video was helpful in giving you some practice on how you can use augmented matrix to solve system of equations. Thank you for watching.